Gravity is vital to our existence, but do you know why it exists or what it is? Why is something that we can't see so important to our survival and the workings of the solar system? What is gravity and what does it do? We all know that gravity exists and that it keeps us on the ground. Gravity is a force that pulls objects towards itself. The word gravity comes from the Latin word gravitas, which means weight. Gravity is the reason why all the planets stay in orbit around the Sun. Who discovered gravity? Isaac Newton was an English mathematician and physicist. He realized what gravity was when he was thinking about the forces of nature, and saw an apple fall from a tree and wondered why it fell. He recognized that a force must be pulling it down to Earth. Newton's thoughts began to wonder whether this force extended beyond Earth and existed in the solar system too. In 1632, he put forward the concept of gravity and created the law of gravitational force, which helped other physicists at the time discover the workings of the solar system. How do we measure gravity? Gravity is measured in what is called gravimetry, and this measures the strength of a gravitational field. The instrument used to measure this is called a gravimeter. Experiments have shown that the gravitational force varies across the Earth's surface by around plus or minus 0.5%. This is mostly because of the constant movements of the Sun and Moon. Gravimeters are mostly to measure the gravitational field for geophysical surveys. Gravimeters also can be used on the Moon to measure the gravitational field. What would happen to Earth without gravity? Although it is highly unlikely to near impossible that gravity will just disappear, scientists have still tried to predict what would happen without it. An article published by the BBC in 2016 explained that if Earth didn't have gravity, it would most likely break into parts and float away. The ocean, rivers, water would simply float away. The Earth would break into pieces and float in space. The same would happen with the Sun. Without the force of gravity to contain its core pressure, it would explode. What would happen to humans without gravity? As we know from astronauts' experience, living without gravity is not only hard but has negative effects on the body, as we have evolved alongside gravity. NASA astronaut and physician, Jay Buckey, has explored how our bodies would react to zero gravity. When in space with no gravity, astronauts lose bone mass and their muscles lose strength. This is because without a force pulling against us, we don't use our muscles, as we would simply be floating. This lack of use of muscles can cause other effects, such as a loss of sense of balance. This is the reason astronauts have a time limit on how long they remain in space. Because it is weakening their body, which has consequences when they return to Earth. If you were to spend around 3 months in space, then it would take 2 to 3 years to regain the lost bone density. Is there gravity underwater? You might think no gravitational force is in water because we float and we feel lighter, but gravity remains the same in water. When an object or person is placed in water, gravity can still act on the object, but only if an equal volume of the water can go upwards, against gravity. This is known as displacement, so, gravity has to choose which element it will pull down, the water, or the object, whichever has more mass. Do all planets have gravity? Gravity is everywhere, but it is weaker in some places than others. For example, on Earth, if you weigh 100 pounds 45 kilograms, the same person would weigh just 17 pounds 7.7 kilograms on the Moon, 38 pounds 17 kilograms on Mercury, and 253 pounds 114 kilograms on Jupiter. As we can see, gravitational force varies between planets and throughout space. If there is the less gravitational force pulling you to the ground, then you will feel weightless and float. Gravity is highly important to our existence and for the functions of our planet. Without it, Earth and the solar system would not be the same. So the next time you go swimming, use some weights to test out displacement, or next time you throw a ball, watch the gravitational force pull it back to Earth.